Welcome fellow learners. In this video, we will learn how we can quantize any open source large language model available on Hugging Face in few easy steps. Specifically, we are going to quantize Llama 3.1 model, a recently released open source LLM provided by Meta. We are going to utilize llama.cpp to quantize this Llama 3.1 model. The main purpose of llama.cpp is to enable LLM inference with minimal steps and provide state-of-the-art performance on wide variety of devices locally or in the cloud. The specific reason why I'm using llama.cpp quantization method and not any other quantization method like GPTQ or bits and bytes is to make sure that the quantized model will be able to run on both CPU and GPU. The main purpose of quantizing these models are to make sure that we can reduce the sizes of these models without hampering the accuracy, such that we can run it in low compute resources devices also. Like usually people have their devices of having 16 GB of RAM or 8 GB of RAM with like 4 GB of GPU or 6 GB of GPU, or sometimes they do not also have any GPU. For those kind of devices with less compute resources or low compute resources, the quantization of these large language models is necessary. So let's get started with the implementation part. So in the first step, we are going to download this Meta Llama 3.1 model. We are going to quantize this 8 billion size of this Llama 3.1 model. So before downloading this, we need to log into this Hugging Face Hub. To log in into this Hugging Face Hub, we are going to utilize this notebook underscore login module. So let's run this cell and it will prompt us to enter the token. As you can see, I have already written down this token over here. And if you want to create your token in Hugging Face, you can go to this profile section of this Hugging Face. You can click on this settings, and then over here you will be seeing this access token tab. You can click on this access token tab, then you can click on this create new token, and then select this read tab and provide the name of the token and create token. Then copy that token, and over here, over in this particular section, you can paste your token. And once you have done that and clicked on this login button, you will be logged into this Hugging Face Hub in this particular notebook. Now, once the login has been successful, we can download this model. So to download this model, we are going to utilize this snapshot underscore download module provided by Hugging Face Hub. So let's run this cell. One more thing you will notice over here, I have provided the base model. This is the basically the path of the folder where I am going to download this Llama 3.1 model. Other thing is this ignore patterns parameter. So if you see, I am ignoring this .pts type of files over here. So the reason is, if you go to this Hugging Face Hub and then go to that Llama 3.1 8 billion page, you will see uh, over here in this files tab that there is a folder named original. Over there a file named consolidated .o.pts, which is of around 16.1 GB, and we do not need that particular file, as we are going to utilize this safe tensors file and directly going to utilize these safe tensors files, and then we are going to quantize this particular llama 3.1 8 billion model. So let's wait for a while until this particular model is being downloaded, and it will be downloaded over here. I have created a different folder, this original underscore model. Over here, this model will be downloaded. Now you can see all these files have been downloaded in this particular original underscore model folder. So let's go to the next step of quantizing this particular llama 3.1 8 billion model. So in the next step, we are going to clone this llama.cpp GitHub repo. So you can go over here, this llama.cpp repo, and you can see in its description how to use this llama.cpp to quantize this particular any large language model available on Hugging Face. And those steps I am following over here. So like I need to first clone this llama.cpp in this particular notebook. Now once this llama.cpp is cloned in this particular Colab space, we can quantize our that llama 3.1 8 billion model. But before quantizing that llama 3.1 8 billion model, we need to convert that model, those safe tensors file, in particular GGUF format, which is basically accepted by this particular llama.cpp. So these are kind of file format which are being required to use this llama.cpp. So let's first create a models folder where I'm going to save this particular GGF formatted model. So let's run this cell. It will take few minutes to convert this llama 3.1 8 billion model to particular this GGF format. And one more thing is like you will be seeing this FP16. So this particular conversion will convert this complete model into half precision of size floating point 16. So let's wait for a while. Now you can see this Hugging Face model, which was in .safe tensors format, has been converted to this .gguf format. So if you see over here in this particular models folder, this llama 3.1 fp16.gguf file has been created. To convert this particular model, this llama 3.1 of .safe tensors format to this particular .ggf format, I have utilized this convert hf to ggf.py file that is provided by llama.cpp. So if you see, we have cloned this llama.cpp over here, and under this folder, if you scroll a little down, you will see this file is available over here. So you can utilize this particular convert hf to ggf.py file to convert these Hugging Face models into ggf format. So now we have converted this. In the next step, we are going to build this llama.cpp such that we are able to use this llama quantize tool to quantize this particular model. You can see I have created this build folder under this llama.cpp folder, and then use cmake command to build this llama.cpp. So let's run this cell. It will take few minutes, like 5-7 minutes, to complete this particular command and build this llama.cpp. So let's wait for a while. So now this build process has been completed. So in the next step, we can utilize this llama.cpp to quantize our llama 3.1 8 billion model. So for that part, we are going to utilize this particular command. So if you see, we first need to change directory to this particular llama.cpp build and then bin. So this is the build folder that we have created in the previous step. We need to change directory. We need to change our current directory to this particular path. Then we can utilize this llama-quantize tool to quantize this particular llama 3.1 8 billion model. In the next few parameters, you can see first I have passed that model path, that GGF model path, and then I have passed the output model file path which I want to create. And after that, I have passed the quantization method type. I have utilized this Q4KM. This will quantize this model to 4-bit, and then it will utilize less memory and provide more efficiency. So let's run this cell and wait for a while to complete this quantization. And if you see, this will basically save this particular quantized model to that same folder, that models folder, this one. You can already see this file has been created. As now it might be having less size, so you can see over here it is only having 7.47 MB size. So let's wait for a while. Now this quantization process has been completed. It took around 40 minutes to quantize this llama 3.1 8 billion model, and over here you can see the size of the quantized model. So it is of around 4.58 GB. Next, we will be utilizing this quantized model for the inference part, and for the inference part we are going to utilize a wrapper around llama.cpp. We are going to utilize a Python wrapper such that we can use a Python library to inference these quantized models. So let's run this cell. One more thing you will be seeing is like I'm using this particular version to install this llama cpp Python library. The reason is I was using the latest version also, but those versions were not compatible with this Google Colab. That's why I'm using this particular version of this llama cpp Python. So let's wait for a while to install this particular library, and once it's been done, we can use this library for the inference part. Now once this library has been installed, this llama cpp Python library, we can import this llama module from this llama cpp. Now we can simply use this llama module and pass the model path for this particular model path where we have saved this model, this llama 3.1 q4km.ggf model, and we will be able to use this model to inference. So let's run these cells. Now this is loading the model. You can see all the parameters over here. So you can see the vocab type, number of vocabulary size, the context, and all parameters are written over here. One more thing, like you can see over here, currently it is using only CPU. It is not using any GPU because you can see this BLAS parameter is 0, which means that it is not using any GPU for now. Now this model has been loaded. So let's use this model for the inference part. You can see I have passed few simple parameters for the generation over here. Go as false. It will make sure that the uh, user's query will not be printed in the output, and the top k as 1, which will make sure that prediction is greedy. So let's run this cell and let's see how does it respond. So now we can see it has provided us this result. The inferencing with this quantized model has been done, and the question that I have asked to it is like, which country hosted 2018 FIFA World Cup? So like over here you can see it has given us this result, like 2018 FIFA World Cup was the 21st FIFA World Cup, and over here we can see like it has provided us the result like it took place in Russia from 14th June to 15 July 2018. The only thing that concerns over here is like it took around 2 minutes to run this particular query in this CPU version. But that's okay for now, as we are able to quantize this model and we are able to successfully do inference using this quantized model. Now, how we can utilize this model at a later time. So like once this session with this Google Colab space is ended, how we can utilize it in our local system, or how we can save it somewhere such that we can utilize it at later time. So there are two ways. One is we can push this model to our Hugging Face space, and another one is we can save it to our Google Drive. So like saving to Google Drive will make sure that your model is private and this will be only accessible to you. And if you want to push it to Hugging Face Hub, that model will be publicly available. And if you want to save it privately in Hugging Face Hub, you might need to subscribe to their pro version. So to save this quantized model in Google Drive, we first need to mount our Google Drive to this particular Google Colab notebook. For that part, we are going to utilize this drive module from this google.colab library. So let's run this cell. Over here, we can see it has asked to connect to Google Drive. Let's click on that and let's access our particular Gmail account, where we will be giving this particular notebook access to our Google Drive. Once we have done that, we will be able to access that particular Google Drive where we can save this model. Now to save that model, over here you can see I have created a folder in our Google Drive. Under this My Drive, I have created this llama models folder, and after that I have used this subtle library to basically save that particular quantized model to that particular folder, this llama models folder. I have already done that. That's why I will be not running this cell again. But if you run this cell, you will be saving your this quantized model to your Google Drive. Now to save it to your Hugging Face workspace, you need to first have a access token which has write access. So you can go to your Hugging Face web page, and over here in your profile section you can go to this settings, and in this particular access token tab you can create new token, and while creating new token make sure that you select this write tab. Once you selected this write tab, you can create your token and then copy that token and then utilize it over here. So like you can see this particular token I have used to log into this particular Hugging Face Hub. Now after logging into Hugging Face Hub with write access, we will be utilizing this HF API module to basically push our this particular quantized model to Hugging Face Hub. Now to save this particular quantized model to your Hugging Face Hub workspace, you need to first create a model ID. So first part in this model ID is my username, and then second part is basically the name of that particular quantized model workspace that I want to create. The other few things that I have passed over here is like path of that particular file, from where we need to copy that particular model, and the path at which we want to save our model in our particular Hugging Face Hub. So these few things we need to pass. I have already done that. And if we copy this particular model ID and search it in this particular Hugging Face Hub over here, we can see that this model is available. And if we go to this files tab, this llama 3.1 Q4 KM GGUF file has been stored in this particular Hugging Face workspace. Now in the next step, we will be utilizing this quantized model with GPU such that we get better inference time and also reduce model load time. So for that part, first we need to change this runtime type, and we can do it from here. We can change this to T4 GPU and save it. then it will be connected to a T4 GPU. Now as we have connected to that T4 GPU workspace, we will not be having that particular model that we have quantized over here in our that content folder. That's why we need to fetch that model from where we have saved that model. So as you have seen that I have saved it in that Hugging Face sub workspace. I will be downloading it directly from there. I will be utilizing this snapshot underscore download module to download this particular quantized model that I have saved it in Hugging Face workspace. So let's run this cell, and we will be downloaded that particular quantized model in this quantized models folder. So over here you can see this quantized models folder has been created, and this particular file will be written under this particular folder. So now you can see this particular model has been downloaded. So let's utilize that llama cpp python to basically do inference using this quantized model. Now to run this quantized model in GPU, first we need to install that llama cpp python with GPU extension such that we can utilize GPU to inference it. So for that part, we are going to utilize this command. Like we will be installing this llama cpp python with extras. Like we will be utilizing this particular extension to install this llama cpp python, where I have mentioned like I need to use CUDA 12.2. So like you need to see which particular CUDA version is available. For that part you can run NVIDIA SMI, and over here you can see CUDA version 12.2. So similarly I have used CU122, which specifies that I need to use llama cpp python, which can utilize CUDA version 12.2. So let's run this cell, and this will install our llama cpp python in a GPU version. So this library has been installed. Now we are going to utilize the same steps that we have used earlier. So like we will be using this llama module from this llama cpp, and we will be passing the path of that particular model, that quantized model. Now one more thing that we need to mention over here is the number of GPU layers that we want to be offloaded to GPU. So I have passed -1, which makes sure that all the layers has been offloaded to GPU. So let's run this particular cell. Let's first remove these lines. Let's initialize our model. Then after that, then once model has been loaded, we can run inference on that particular model, and let's see how much time it will take this time. So now this model has been loaded. Now we can run our inference part. So let's copy the same arguments also that we have passed earlier. So let's copy that directly. So we can copy this one, and we will be running the same over here, so that we can see that how much time it will take this time. So let's copy paste over here, and instead of LLM, let's change it to model, and let's run this cell and see how much time it will take this time. So here you can see it ran within 6 seconds, and over here we can see the result. It provided the similar result like 2018 FIFA World Cup was the 21st FIFA World Cup, and it took place in Russia from 14 June to 15 July 2018. So it's great. We can see that by utilizing GPU, it's really faster than when we were using CPU to run inference over this quantized model. So now you have got clear understanding of how you can quantize an open source LLM by utilizing llama.cpp, and then you can save it to either your Google Drive or a Hugging Face hub, and then you can utilize that same saved model for inference part at later time. And the major benefit of using this llama.cpp is that we can use this quantized model and do the inference either in CPU or GPU both. So like you can do inference in your local system also, which are having less compute resources. As you can already see, like this model is having only size of around 4.58 GB. The original model was taking around 16 GB of space. So like you can load this model in your local system also, where you are having less compute resources. So great. Thanks for making till the end of this video. Goodbye until the next time.